Hello, everyone. It's great to see you guys all out here today. I am super excited to talk about S3 because here at a security conference, everybody should be concerned about S3. Anybody here have data in S3? Raise your hands. Anybody who didn't raise your hands, raise your hand because you do have data in S3. Somebody else has data on you in S3. Just the way it works, it's the largest web service in the world, and it's a great place to work. A little bit about myself. My name is Brian Cutler. I'm a principal engineer on the S3 security team, and I've been with Amazon for about 15 years. For the last 5 years or so of that time, I've actually been a dungeon master. I've got a group that plays D&D on a weekly basis, and what I've learned from being a dungeon master is that people have a really easy time doing the right thing if they understand the core concepts. If they understand the basic rules of the game, you can tell incredible stories. And so I'm hoping to do that today with S3 to give you some of the basic concepts about presigned URLs so that you can make the right choices and tell your own amazing stories with S3. So agenda-wise, we're going to be talking about presigned URLs. Specifically, we're going to talk about how they work, what exactly they are, when you should use them, and when you should not. And then also about the alternatives that AWS offers to presigned URLs. So to understand presigned URLs, we have to understand two things. We have to understand presigned and URLs. And presigned means that you need to understand about AWS authentication. Basics on the way AWS authentication works. You are given a secret key by AWS. You use that secret key to sign requests, and those requests come to Amazon S3 or any other AWS service with that signature attached. So the first thing that AWS has to do is check to make sure that that signature is correct, cryptographically correct. Given the string that we extract from the request you give us and the key we then know that you're supposed to possess, do we compute the same signature exactly that you computed, right? So this is about can we prove that a specific key was used to sign this request? And it's astronomically unlikely that any other cryptographic key could produce the same result. But in addition to checking whether the signature is correct, we need to know if the signature is valid, right? Not just that you did sign the request, but we need to know, is this access key still active? Have you deleted this key or disabled it? We need to know, is your account an account in good standing? Did you stop paying your AWS bill and get cut off? Have you been convicted of some sort of fraudulent behavior? We need to also make sure that the timestamp in that request is within a small delta or epsilon of the current server time. We want to make sure that somebody doesn't observe one of your signed requests and then send it to us a year later and we say, yep, that signature is correct cryptographically, and honor that. We don't want to replay a request. So we've got this timestamp that has to be checked to be within some bound of the current time. So that's your authentication basics. So the next question is, what is a pre-signed URL? I want to address one of the biggest misconceptions about pre-signed URLs first. Pre-signed URLs are not just signed requests with some timestamp in the future. We see this a lot. People say, I'm going to create a pre-signed URL for a DynamoDB call, or I'm going to create a pre-signed URL for Elastic Container Service. And those services don't offer pre-signed URLs. You can sign requests ahead of time. But with pre-signed URLs, that's specifically an S3 feature. It's different in two significant ways. One of those ways is that we relax that time constraint. Usually we would say, plus or minus 5 minutes or plus or minus 10 minutes from the time of your signing. But in this case, we accept a expires signature parameter that tells us how long a request should be considered valid. And that could be much longer than that typical delta. So a normal request, plus or minus just a few minutes from the time in the signature timestamp. And with an S3 pre-signed URL, that might be a week that it's valid. It might be multiple days that it's valid. And it's valid all the way up until then, the entire duration of the time between now and that expiration time. The second thing is the URL part of pre-signed URL. A presigned URL uses query parameters rather than HTTP headers for all of its signature parameters and other request parameters. That means that the whole thing becomes a string, right? A URL that can be passed around. It's not a complex HTTP object. This has also some implications for S3 specifically. S3, you're going to be uploading like a file as your HTTP body contents, and that's typically not known what that's going to be in advance to the user of a presigned URL. So when I create a presigned URL, I'm going to use a placeholder for the value of the body of the request. I'm not signing what that object is going to be that I'm going to upload. I am just creating a placeholder so that whoever I give that URL to is going to be able to upload a file. So here's an example of a presigned URL. I've redacted the security token here, but you can see that there are a bunch of query parameters that all look like HTTP headers because they're just headers that have been stuffed down into the URL. XAMZ security token, XAMZ date. You see in pink, we've got the XAMZ expires. That's a special parameter just for presigned URLs. This 300 means that it will expire 5 minutes from the time that the request was signed. So typical usage of these things is that a human being goes and asks a service to generate a presigned URL. And that service uses its own AWS credentials. That can be any type of AWS credentials, root users, IAM users, assumed roles, right? Temporary sessions, federated sessions. It uses those credentials to sign the request, hands the URL back to the user, and then the user either clicks it themselves or they hand it off to somebody else. You might send that link via a text message or via email. It might sit on a thumb drive for 3 days and then be plugged in and used later on. And that second user doesn't have to have any AWS credentials themselves. They don't have to have any permissions or anything. They are just going to fetch the contents of that URL and get back a response as though the request signer, the server in this case, had made the request directly. So the benefit here is that I've temporarily allowed an anonymous user, another human being who does not have an AWS account, to access my data in S3. Now there's another use case here which is not human-facing, it's more of an application. So I could have an application that asks for a presigned URL, gets it back from a signing service, and then uses that presigned URL to talk to S3 without having any AWS credentials of its own. And in this case, it's not really that the app is anonymous or that the app doesn't know what AWS account it's from or anything. The benefit here is really that we've moved the signing out of the application and over into the signing component on the server, right? It's about shifting where that signing occurs. So question is, when would you ever use pre-signed URLs? What are the reasons that you would? One of those reasons is that you might have a device that's extremely constrained, right? This is an IoT device. You've got a sprinkler head or a light bulb or something. This light bulb does not have the compute capacity to sign AWS requests or to compute cryptographic operations at all. It just wants to fetch a config file from the internet. Another situation might be that you have just a totally generic client, right? This is, I want my web browser to go fetch this thing. The web browser has plenty of compute capacity to sign requests. It could have an SDK embedded in it in JavaScript, but I don't want my end user to have to set anything up. It's just a super generic client. This could be Chrome, Firefox, this could be curl on the command line. I just want my generic client without any other setup, without any SDK, to be able to make a request. There's a third reason you might want to use a pre-signed URL, and that's that the end user that you're giving access to doesn't have an AWS identity at all. I want to share my photo with my friend. That friend has no relationship with AWS at all, but I've got storage in S3. So if I want to share that with them, rather than opening up my bucket to the public at large, I can share just an individual file with a specific friend by giving them a URL. And finally, we've got a situation where you want very granular per object control or per request control. So if I want to have 1 million users that each share 3 out of my billion files with a friend, there's no way to write all that succinctly into an access control policy. Your 20 kilobytes of bucket policy or of session policy are going to be eaten up really quickly. And so if you can generate those temporary links on the fly for specific files, you can scale that up much more broadly. So these are your main reasons to use a presigned URL, but why should you not use them? This is the cautionary note here. For one thing, presigned URLs are only relaxing that time constraint. They're not relaxing the restraints on the validity of the credential. So if your account isn't valid anymore, if your access key isn't valid, if you've rotated your keys, or if your session has expired, then those presigned URLs don't work anymore. That might be a major limitation for you, that you want to share something for a year, but your temporary session expires 6 hours from now. Presigned URLs never outlive the credentials used to sign them. Another thing is that the presigned URL is always for a specific operation. So I might want to give someone permission to put an object, but that allows them only to put an object into S3. It doesn't allow them to do a multi-part upload to S3, or to put an object with some tags associated, or to put an object with a checksum attached, right? Everything about the request has to match what's in the URL. And so if you want to give someone access to a series of API operations or a set of files, every single one of those needs to be a distinct presigned URL. And so if you've got a bunch of things you want to do, presigned URL isn't going to be your best option. It does one thing, one time. And finally, presigned URLs are bearer tokens. Bearer tokens is a scary phrase in the security world, right? What is a bearer token? A bearer token means anyone can use that token to access your resource. People worry about this all the time. You worry about, what if my presigned URL gets picked up by somebody off the street and they use it instead of the person I intended to use it? When they do use that, the audit record is going to show that the signer made the request. There's no visibility into who the user was who actually clicked the link. So if I share my link with Bob and Bob gives the URL to Dave, I have no idea that it was Dave that clicked that link. It just says that my URL was used. Presigned URLs also relax that time constraint, and so they are replayable for their entire duration. I might only want it to be used once, but if it's used once at the end of a month, that means that for the whole month leading up to that, it's been valid. And then the last one is that these things are only revocable by changing the credentials or the permissions of the user who signed those requests. Creating a presigned URL as a signing technique is entirely a client-side operation. There's no S3 API call used to create a presigned URL, so there's not a permission that's exercised, there's no policy that's enforced. Any user, any principal can create a presigned URL, and so there's no knowledge on the server side about what presigned URLs exist or which ones are valid. There's no way to revoke that outside of rotating a credential or changing a policy. And that would affect all the presigned URLs created by a specific principal. So, should you be afraid of presigned URLs? These are bearer tokens. They're limited in duration. They only do one thing, right? And the answer is no. Do not be afraid of presigned URLs. You don't need to block them. You don't need to freak out about them. You don't need to worry about the fact that users can't create these presigned URLs, because there are ways to mitigate all of these risks. Most importantly, you need to always carefully bound your signer's permissions. Presigned URLs don't give you any access that the signer didn't have. And so if a signing principal in AWS does not have access to a file, they can't create a useful presigned URL that will point at it. Your files are still safe. Principle of least privilege is a well-known concept, and if you follow that, your users' presigned URLs will also follow that principle of least privilege. You should not be signing, or you should not be logging request signatures here. Presigned URLs, if they all get stored into like a log in a proxy someplace, like anyone who has access to that log now has access to those files. But this is best practice anyway. You should not be logging secret materials, and these temporary signatures as bearer tokens are definitely supposed to be secret. You can also keep the total duration of your presigned URLs very short. While we talked about sharing for a month or sharing for 6 months with someone, usually what that means is that I want to create a long-lived grant of some access but I don't need a pre-signed URL to actually be valid that long. I can just request a pre-signed URL in the moment that I need one. And so if you build an application that is going to share files, you can do on-demand requests for pre-signed URLs and keep those total durations of the pre-signed URLs super short, on the order of like 5 minutes. This is the same thing that the AWS Management Console does. When you download a file in S3, it generates a short-lived pre-signed URL for you. It doesn't create one at the very beginning of your AWS tenure and leave it valid until the day that you might decide to use the file. It keeps that duration short and delivers it just in time. And then finally, you should be able to use a temporary session for all your signing. This puts a hard limit on the duration of the URL. If my temporary session credential is only valid for a few minutes, my pre-signed URL is only going to be valid for a few minutes. It also allows me with my scope down policy that I use when I assume a role to scope the access that that pre-signed URL is going to have even more tightly than what the signing role has. So the great thing about this is that these are all best practices already. If you're already doing all these things, then pre-signed URLs aren't scary for you at all. You're already mitigating all of those risks. But let's talk about alternatives. Pre-signed URLs are not the only way to share objects in S3 or to temporarily grant access to S3 data. First one I'd like to talk about is Amazon Cloudfront. It's a great option if you are trying to share content with users in a web browser. Pre-signed cookies in Cloudfront allow you to access more than one file. It could be all the files in a specific prefix in your bucket or all the files in a bucket. Those pre-signed cookies support custom domain names with TLS, so your HTTPS padlock will show up in the browser. It's a better experience in a lot of situations for customers who are supposed to be able to download all their files from your media library. So definitely consider Cloudfront signed cookies if you have a web-facing use case. The next one is a variant on that request response just-in-time get a pre-signed URL architecture, where you don't create a pre-signed URL, but you create a signed request. That might be sort of a pull-through model where you talk to a signer that proxies all your requests for you, signing them on the way out and then returns the responses. Or it might be more of a sidecar where you ask a signer locally to sign your request and hand you back a signature, which you then use as normal. This preserves all the benefits of the client device, not needing to have a big SDK, have its own AWS identity, have the compute capacity to do the signing itself, but it also doesn't get you into pre-signed URL territory where it might be valid for a longer period. These end up being normal AWS requests. The downside of these approaches, of course, is that the signing component needs to be online all the time. Your availability is going to be bounded by the uptime of that component. Another alternative is S3 access grants. These were launched last year at reInvent. Access grants are an instance of a token vending machine pattern. It's a system that will vend credentials on the fly, on request, to AWS SDK whenever you ask for a specific S3 file. These grants give you read or write or read and write access to files, prefixes, or buckets. And the great thing about these is that you can use them with identities other than AWS identities. You can use them with identities from your own corporate directory that's been synced with AWS via AWS Identity Center. That means that that problem we had in the beginning of a user who didn't have their own AWS credentials, you can solve that problem. My end user who doesn't have an AWS account but does have a corporate account with my identity provider can now exercise those grants and use an SDK even if they don't have their own credentials or account or user. So just to review here, we've talked about how AWS pre-signed URLs are not the same as requests signed in advance. They do relax that time constraint, and they do pack everything into URL parameters. There are valid use cases for them if you've got anonymous users, if you've got low-powered devices, if you want generic devices to be able to talk to S3. There are valid use cases for them, and you should think about them as an option when you're designing your architectures. But you don't have to be afraid of them. While they are bearer tokens, normal AWS best practices will mitigate all those risks associated with a pre-signed URL. And finally, there are alternatives. Access grants especially is going to be a way that we recommend for a lot of customers to move forward on this. Access grants have so much flexibility, and there's more coming soon on access grants as a feature. So I'm really happy that you guys all came out to hear about presigned URLs. It's a topic near and dear to my heart. I've been 5 years in S3 security. We get questions about this all the time, and so I'm hoping that today you've all leveled up a little bit, right? Your intelligence and your wisdom scores are now +1, right? So you can go out and face this dungeon with confidence. Thank you very much for coming to hear about presigned URLs.